Today, we're diving deep into the world of large language models, also known as LLMs. So let's get started. The rise of LLMs have revolutionized natural language processing, and it's allowed companies to now seamlessly integrate AI into a wide range of tasks, things that have never been possible before. And these models have evolved from being task-specific to now becoming versatile tools capable of handling pretty much everything. From startups to large companies, everyone, and I mean everyone, is leveraging the power of LLMs. Giants like OpenAI, Google, and Meta lead the charge, while newcomers like Mistral AI and Databricks are also making significant strides. The versatility and the performance of LLMs have made them indispensable in the world of tech today. And it's gotten to the point where if you are not using AI on a daily basis, you are falling behind. When selecting an LLM, I think it's crucial to understand the benchmarks. These benchmarks help us evaluate model performance on various different tasks, but I think it's also important to understand that they do have their limitations as well. For example, things like data leakage. Often, test data leaks into training assets, causing models to memorize answers. This will in result skew leaderboard results and doesn't always accurately reflect real-world performance. Not to mention errors. Some leaderboards have fundamental flaws and errors, so their rankings should be taken with a grain of salt as well. And just like what I mentioned with point 1, real-world performance is a very important factor. Benchmark performance might not correlate directly with domain-specific tasks, especially if your use case differs from the benchmark scenarios. Of course, there are many different benchmarks, all with different pros and cons. I think it's generally a good practice to look at model performance across various different benchmarks to find out which one really works for you. Now, if you want to learn about different benchmarks, I'll make sure to put a link to our blog post below for you to check out. So then, why should we experiment with different models? Well, choosing the right LLM isn't just about picking the top model. It's essential to consider various factors such as cost, speed, and what specific capabilities you need for your application. Experimenting with various models will help you find the best fit for your needs. For instance, if you're developing a local application where models are meant to run on a device, using a large model would be very slow, right? And almost unusable. However, swapping two different open source models and augmenting them with external data using techniques like retrieval aug generation, aka RAG, can actually bridge performance gaps and reduce costs on your end as well. So then, okay, Chris, what should I actually consider when picking an LLM? Number 1, performance. Models are typically evaluated on standard benchmarks and ranked based on scores. Depending on the use case, consider benchmarks like MMLU, which stands for Multitask Language Understanding for general knowledge, and Human Eval for code-related tasks. Secondly, costs. No one has unlimited money. LLMs are usually hosted by a company and priced per token. Costs can vary significantly. For example, smaller open source models like Llama 3.8b cost about 20 cents for every 1 million tokens, which costs significantly less than GPT-4, which costs $30 for every 1 million tokens. The next important thing to consider is 100% output speed. Depending on the use case, speed can be crucial. In real-time applications like voice applications, slow responses can impact user experience, whereas speed may be less critical for, let's say, a task that requires you to process meeting transcripts overnight. Now, there's a lot more things to consider, but the last thing I just want to mention is privacy. Proprietary models from companies like OpenAI, Google, and Anthropic are accessed via API, requiring data to be shared with the hosting company, right? For some applications, this is acceptable, but in others, using an open source model that can be hosted locally might be better, ensuring your data remains on premise. Now, last but not least, which model should you use? So here's a general guide for picking a model for yourself. Number 1, start with high performance models like OpenAI's GPT-4, Google's Gemini, or Claude's Opus to ensure high output quality during prototyping and development. 2, after establishing a baseline with a high performing model, explore swapping in different models based on specific use cases and cost considerations. Believe it or not, techniques such as supplementing with few shot examples or connecting to external tools can actually help you match the performance of larger models. Last but not least, I think it's important to consider other benefits beyond performance, for example, speed. In some cases, a slight drop in performance might actually be acceptable if it results in significant improvements in generation speed or cost savings. By experimenting with different models and techniques, you can optimize both the cost and performance of your LLM applications, potentially achieving better results than sticking with a single model. Navigating the landscape of large language models require careful consideration of multiple factors such as performance, cost, speed, privacy, and specific capabilities. By understanding these elements and experimenting with different models and techniques, you can make informed decisions to harness the full potential of LLMs for your project. Anyway, let me know what y'all think of the video.
And if you want to dive deeper into the world of LLMs and get more detailed insights, make sure to check out our blog post in the description below. I hope y'all like it. I'll see y'all in the next one. Peace.